Let's work through the 1D array practice example called left shift. This is one of many uses of an array and involves manipulating the contents of an array so that elements are moved or shifted one or more places to the left, with the first element circled around to the back each time. For example, let's look at this array of 5 elements called list, containing the values 2, 5, 7, 3, and 4. The call, shown here, is to shift all elements 2 places to the left. As you can see, the code has 2 sets of loops, one nested inside the other. The outside I loop represents the number of shifts, since it uses the variable places in the check. The action of this loop is the one that does the actual shifting. Let's look closer at the code. The first thing that happens is that a copy of the first value of the array is saved with the statement int first gets list 0. Then a for loop, the inside one using the control variable j, starts at 0 and then does some sort of a check, some kind of a condition, and then performs the shifting action by assigning to the current position of j the value in the neighboring position of j plus 1. It then takes one step towards the end of the array. Once the j loop stops, the last step is to put the first value that was saved into the last position of the array, which is what this statement means. The last position of the array is one less than the length of the array. The question now is this: what should the condition be in the j loop to make this process effective? Think about it for a moment. Here's the idea. The j loop traverses the entire array, shifting values each time. The most important thing whenever you are processing any array is to always stay in bounds. The missing condition is what keeps the loop safe, to keep it in bounds. You must ask yourself what condition will ensure that this loop always stays in bounds. The answer is that j must not go past the next to last position of the array. Why the next to last? Why not the last? Because the assignment statement inside the j loop accesses the j plus 1 position, which means you must not let j go too far so that this would cause an out-of-bounds error. So the condition should be j is less than the length of the array minus 1. The length of this array is 5. There are 5 elements. The value of the last position is 4. And so the farthest j can safely go is less than 4, or position 3. Let's work through this call to see how all this works. First, we save the first value, the one in position 0, which is 2. Then the j loop does its work, going from position 0 to position 3, the next to last position, assigning to the current position the value in the next door neighbor position, j plus 1, achieving a single shift of the array. Position 0 gets the 5, position 1 gets the 7, position 2 gets the 3, and position 3 gets the 4. Now that all of the values have been shifted, the saved first value is then assigned to the last position, which gets the 2. The contents of the array now have been shifted one position to the left. The outside loop acts one more time, since we are shifting 2 places. This causes the inside loop to execute all over again, but this time, the first value saved is the 5. And then the remaining values are all shifted over one place as before. And finally, the 5 is assigned to the last position of the array. As you can see, the condition of the inside loop, the j loop, must keep the j control variable within the confines of the array, which means for this array, it must stop at position 3, the next to last position of the array, indicated by the statement j less than length list minus 1.